Hello, everyone. I am Giulia Piantoni, and I am one of the co-authors of the work entitled Resilience of Territories in the Face of Hydrogeological Risk, the Role of Mitigation Interventions in Lombardy region. My co-authors are Professor Giovanni Azzone and Professor Teresa, PhD student Teresa Bortolotti, and the PhD candidate Sara Ratti. Our submission number is 0432 for the Data for Policy Conference 2022, and all the authors are from Politecnico di Milano. Some of us are from the Department of Management, Economics and Industrial Engineering, and some of us from the Department of Mathematics. In this time that I have with you, I'll talk about the context and problem, research gap and question, the state of the art, research design, the determinants of resilience, which is quite key in our work, the main findings that are discussed in the end. So to begin with, as our title says, we are focusing on hydrogeological risk. In particular, it is becoming increasingly relevant also due to the impacts and effects of climate change. If we focus on the Italian territory, which you see on the right of the slide, we can see that more than 90% of the Italian municipalities are characterized by risk of landslides, floods, and coastal erosion. And more than 90% of the Italian municipalities have a high hydrogeological risk. Having a high hydrogeological risk is very critical for municipalities because it can affect the attractiveness and resilience of the territory itself. If we look at the Lombardy region, we can see that it is quite critical and interesting to be studied for three main reasons. First, over 40% of the municipalities of this region are characterized by a high or very high hydrogeological risk. Then the Lombardy region is the most populous one in whole Italy, and it also is very relevant in terms of socio-economic perspective as it contributes to more of the 20% of the Italian GDP. So we are studying the hydrogeological risk in Lombardy region. We have said that hydrogeological risk is increasing, it is very impactful, and therefore, there are mitigation interventions that are provided in Italy by the public to mitigate the effects, the potential effects of hydrogeological phenomena. And these mitigation interventions are publicly funded and are provided, for instance, to the Lombardy region for an amount of more than 300 million euros for concluded interventions between 1999 and 2022, which is around 10% of all the publicly funded concluded interventions in that period in the Italian territory. Considering the context in which we're moving and the literature that we reviewed, we spotted two main gaps. On the one hand, the literature often indicates hydrogeological risk and its position to hydrogeological risk as one of the potential determinants of resilience and attractiveness of a territory. But there's no study that structurally quantifies the relationship between hydrogeological risk and systemic resilience of a municipality. So our first question is hydrogeological risk related to systemic resilience in a municipality, and how is this relationship? And then the second gap and second research question. So when we focus on mitigation interventions, we know that they are made for mitigating hydrogeological risk. And we know that probably they could have some effects also on other aspects of the territory. So we don't know actually whether these kind of interventions could also have an effect on the resilience of a territory. So our second research question is, to what extent do interventions of hydrogeological risk mitigation affect resilience of a municipality? So our aim is to define and analyze resilience of territories in the face of hydrogeological risk first by looking at the relationship between hydrogeological risk and systemic resilience of a municipality, and second, looking at the role and impact of mitigation interventions on hydrogeological risk. To do so, first, we looked at the literature and we noticed that we focus more on two pillars of the literature. On the one hand, on hydrogeological risk, landslides and floods. On the other hand, on resilience definition, mainly focusing on systemic resilience and studies on the Italian territory. So, considering the first pillar, we can say that the literature on hydrogeological and landslide risk provides definition of this concept and relates this concept to exposure, hazard, vulnerability, and resilience, of course. There are studies on social risk and others focusing on the effects on wages, income, and on environmental justice. Mainly, studies in this reference literature are focusing on specific single cases, specific disasters, areas, and so on, but there are no structured studies using data sets, database on interventions, or connecting them to resilience, for instance. Talking about resilience, there's no unique definition of the resilience. There are diverse types of resilience that exist, and we could see that the type of resilience that is closest to our study is systemic resilience. And resilience can be seen both as a process and a composition of determinants. And we are applying this second version of definition of resilience, looking at it as a composition of different determinants. So, given this state-of-the-art analysis, our research is designed in main steps. First of all, we had to define resilience, identifying the main determinants other than the ones related to hydrogeological risk and physical vulnerability, which we don't want to insert into this indicator of resilience. We then collected data at municipal level for the Lombardy region, proxying the identified determinants, and that was not easy at all because lots of data are not available at municipal level, but mainly at regional level. Then we constructed the dataset using the unit of analysis, the municipalities in Lombardy as of 2022. So we have 1,506 observations, and we included in the dataset variables characterizing the municipalities in terms of demography, territory, variables on the hydrogeological risk in terms of mitigation interventions, and of course, determinants of resilience that I'm showing in the next slide. Based on this work, we could compose a unique and synthetic indicator of resilience at municipality level. This indicator is composed as the direct sum of the standardized determinants per municipality. And this choice is supported by the results of a PCA, which does not reveal any relevant correlation structure among the variables. Thus, there is no redundancy in the identified determinants, and we could use all and just sum the standardized determinants to find the composite indicator of resilience. And then we performed our statistical analysis for answering our research questions. For answering research question 1, we verified and quantified the relationship between resilience of a municipality and its exposure to hydrogeological risk, considering the classes of risk provided by Arini et al. For the Lombardy region, Arini et al. 2023. And we employed the Mann-Whitney-U test to assess the mean difference in terms of resilience across these classes of risk. And then to quantify the impact of mitigation interventions, we considered public funds allocated between 1999 and 2022 for concluded interventions, and we could have them from Rendis as a source. And we constructed both a dichotomous variable and a continuous one on interventions. The dichotomous variable takes the value of 1 if the municipality has received at least 1 funding in the period for the concluded intervention, and the continuous variable is calculated as the weighted average of funding received by the municipality and its neighbors. Then we performed a linear regression model considering interventions as independent variable, and all the analyses were performed both for the whole dataset and for the dataset without the provincial capitals, because we noticed that provincial capitals were often outliers in our determinants of resilience, but I can anticipate to you that main findings remain unchanged. Here you see the determinants of resilience that we use for our composite indicator. They are divided in dimensions: social, environmental, infrastructure, and economic. Concerning the social dimension, we consider as determinant structural dependence, employability, integration, healthcare service defined in terms of distance to the closest hospital, social services, and competencies. In terms of environmental dimension, we just consider land use, and usually in the literature in this dimension, authors also include determinants related to hydrogeological risk or exposure. But as I said, we don't want our indicator of resilience to have these kind of indicators inside. And then in terms of infrastructure, we look both at accessibility in terms of access to transport network and the digital infrastructure in terms of landline internet coverage greater than 100 Mbps per household, considering fiber to the cabinet infrastructure. Last, the economic dimension is composed by determinants related to the financial resilience of companies, competitiveness, and income. Here, I just wanted to show you some examples of determinants, one per dimension. On the left, you see an example for the social dimension, and this determinant of resilience is the distance in kilometers from the closest municipality where there is a hospital. So the darkest the color, the lowest the resilience of the municipality in this case, while municipalities in yellow have a high resilience. And you can spot the provincial capitals, which are all yellow here, while the darkest regions are usually the municipalities which are far away from bigger cities. On the right, you can see an example of infrastructure determinant, which is the access to transport networks. Here, the indicator is calculated in this way. The darkest the color, the highest the resilience, because it means that accessibility is higher. Here you can clearly see Milan, which has indeed numerous airports, railroads, and roads, while the mountains, so the northern part of the region, is colored in yellow, meaning that accessibility is lower, and this negatively affects resilience. If you look at the environmental determinant, we can see that it is calculated as the net increase in land use between 2021 and 2022. The municipalities you see colored in gray here and in the other map on the right are municipalities that have a value equal to 0. In the left map, you see clearly Milan and also other provincial capitals with some outliers that are clearly connected to some construction projects. On the right, you see quite a jeopardized picture, and it is the share of turnover at risk in local enterprises. If we look at the resilience, which, as I said, is calculated as the direct sum of the standardized determinants per municipality, all the determinants. On the left, you see the resilience considering the entire data set, and you see that the municipalities in purple or red are the more resilient, while the ones in yellowish are the less resilient. While on the right, you see the resilience map calculated without considering the provincial capitals that are indeed in gray. But as I said, main findings remain unchanged. So before moving on to the slide on the main findings, here we can see a preview of one of them. Here we have plotted the resilience in municipalities at top hydrogeological risk on the left, in the middle at high hydrogeological risk, which also comprise municipalities with top hydrogeological risk, and on the right, the resilience in municipalities at low hydrogeological risk. And what we can already notice, except from Milan, which is an outlier in this case, is that the maps on the left have more yellow respect to the one on the right, meaning that resilience in municipalities at high and top hydrogeological risk is lower on average respect to resilience in municipalities with low hydrogeological risk. Indeed, so our main findings are these ones by now. So first, all the determinants of resilience, but the share of turnover and the proportion of foreign residents are significantly different at 1% significance between municipalities with medium-low risk versus high and top risk. And in particular, municipalities with high and top risk are on average associated with determinants that adversely affect resilience compared to medium-low risk municipalities. Last but not least, higher funding is significantly associated with a reduction in resilience and an increase in social and material vulnerability. Therefore, two main findings are evident here associated with our research questions. First, there is a quantifiable relation between hydrogeological risk and resilience of municipalities, which appear to be correlated. Second, publicly funded mitigation intervention cannot, at least in the short run, enhance resilience of a municipality. Overall, therefore, we aim at providing some original contributions and interesting implications with our work. First of all, in terms of the methodology adopted. So we employed a quantitative study, we constructed an original data set, and this is quite new in the reference literature. And also we consider municipalities as statistical units, considering a whole region in our analysis, which is, again, quite new in the reference literature, mainly due to the difficulty in data collection and availability. Then we compose a new and unique composite indicator at municipal level to assess systemic resilience of municipalities in the face of hydrogeological risk. And we can also prove statistically the relation between risk, hydrogeological risk, and resilience of a territory. So the more the hydrogeological risk, the lower the resilience of a territory. Also, we could prove the role of mitigation interventions, which actually cannot have an impact in the short run on the resilience of a territory. This can also affect the role and the choices of policymakers, which could, for instance, focus on the correlating resilience and risk. To do so, they should plan some other intervention synergic to the mitigation interventions that might focus on other resilience of determinants of resilience, so to enhance resilience and then correlate it more from the hydrogeological risk. In particular, from our findings, the determinants that results more different among top high risk versus medium low risk municipalities are structural dependence, accessibility, and specialization. So these might be the ones on which to focus more for enhancing resilience in this case. Of course, our study is not exempt from limitations, one above all, availability of data at municipal level. So we are perfectly aware that other indicators might have been better for our indicator of resilience, but they were not available at municipal level. In terms of future studies, we think that the value of the method that we are applying is quite interesting for different reasons. For instance, researchers might stem on our study to perform studies with a longitudinal perspective. For instance, updating the determinants as they change in time and assessing the effect of mitigation interventions on a longer term. Then our indicator, composite indicator of resilience, is of modular nature. So future studies could focus specifically on specific determinants as the ones that I mentioned before. Last but not least, this is quite flexible. Our indicator of resilience is quite flexible, so it can be applied also in other contexts rather than the hydrogeological risk one. So this is some rest. I thank you for the attention, and I hope to see you at the conference this year. Bye, and thank you again.